All right. So my topic is probability-based two-stage CNN for pulmonary embolism detection in computed tomography, pulmonary angiography. I am a Jinn-Yi from MIS National Chiayi University in Taiwan. And today's presentation, I will show you the introduction flowchart of the proposed system, what is the database that we used, and the probability-based two-stage system. One process is called a blood vessel alignment process, and there are some main functions for eliminating false positive for detecting the PE. And I will show you the experimental results, finally give the conclusion. The pulmonary embolism we call PE can result impeded the normal flow of the blood, which can result in the reduced oxygen level in vital organs and be life-threatening. Early detection and the treatment of a PE can effectively reduce mortality. And computer tomography, pulmonary angiography, it's called a CTPA, is one of the most important and detailed techniques for examining the blood vessel inside the lungs. A CTPA image can serve as an important basis for helping doctors diagnose and treat the PE cases. And the radiologists typically detect the dark area of the PE in CTPA images by manually circling contours. This process is time-consuming. It is difficult to determine the blood vessel boundary owing to noisy or artificial interference, and the experienced expert may be required to interpret them clearly. A computer-aided detection system is required to assist doctors during interpretation. So my study proposed a modified two-stage convolutional neural network. It's called CNN approach to automatically detect areas suspected of containing PE and CTPA images. A distribution model is published for the original image based on the PE probabilities. The enlarged feature map called EFM, corresponding to more positive anchor points with better quality, is extracted from candidate region to facilitate the subsequent detection. The entire process can improve the PE detection accuracy without increasing the time required. So this is the flow of the proposed system. This study established an automatic detection method to automatically detect the area suspected of containing PE and CTPA image using the modified two-stage CNN. So first, the CTPA images are read from the PE challenge database. The system then pre-process the entire interpreted image and execute the modified two-stage CNN. So there are two stages. Finally, the performance of the system was then evaluated against the PE detection methods. The database we use in this study contains Clinical data can obtained from 6 different local hospitals. The radiology research center was in Madrid, Spain. The CTPA images dataset contains 235 emboli. The database comprised 3,438 CTPA image with the PE. The database is accompanied by annotations such as the embolism position and the size in each image, which can be used to evaluate the effect of image plating. This image was divided into 2 parts, training sets and test set, as is showing here. I will show you the probability-based 2-stage CNN. The first stage uses a 3D fully convolutional network for extracting candidate regions, and which may be P targets. The second stage extracts 3D candidates after the blood vessel alignments. The 2D cross-section of these cubes were fed into a probability-based resonate 18 classifier to eliminate false positive. And probability, sorry about that. Okay, the next one. The first stage, okay, so this study used a modified 2-stage CNN proposed by Yang et al. In 2018 as a framework for detecting PE, so which is illustrated here. And one key process is in the next slide. It's called a blood vessel alignment process. I will take into the detail shown in these slides. So the A figures is a voxel around the embolus, and the B is a PROI cube, and C is the beginning of the PEROI PCA to determine voxel axis V1 and V2 to orthogonal directions, and use of the V1, V2, and V3 to form a planar image of the cross section showing blue, and a planar image of a longitudinal section showing green. So the E figures shows that the multiple longitudinal and the cross-sectional plane obtained by rotating V2 and V3 around V1. And the F is the division of the rotated planar image into 2 structures. Finally, the F is the emboli are generated by randomly selected 1 planar image from the transverse section and the 2 planar image from the transverse section. So we will get the results. And for this research, we have using some main functions. For example, the first one is called Principal Component Analysis, CPA, applied to the binarized cubes to calculate the orientation of vessel segments in them. The specific methods involves extracting 3 eigenvalues, V1, V2, V3, and their corresponding eigenvalues, lambda 1, lambda 2, and lambda 3. The second main function is called enlarged feature map, EFM. It is used to adjust the sampling stride to obtain more positive anchor points. The third one is called probability-based anchor point extraction, used as an anchor point extraction method based on the probability of a P vascular distribution features. So the results we're showing here, the ACM, then use the distribution feature in combination with the grand scale value to determine the contour of the lung region, showing here. And this one is show the, on the left, show the transverse coronal and sagittal slice image of original P cubes in the three cases. The last one is show the longitudinal and the cross section after the vessel alignment. Okay. And the results using the location distribution of a PERI is showing here. We can find the areas including PE, and the established the Gaussian mixture model is showing here. And finally, the A and the B under the bottom image show the results successfully detection under the positioning error of 0 millimeter. Okay, and but C and D we cannot find the PE, so it's the result of failed detection. And for the numerical results, we have using 3 quotation to show the results. It is 0, 2, and 5 millimeter position errors is showing these figures. And finally, the result of this study and other terms have previously participated in the detecting the P is showing here. Our proposed method is got a very good results. And so finally, a deep learning approach was used to extract candidate region from raw CTPA image by using the 3D FCM through the PCA process of aligning the blood vessels and calculating the regularity of a P region distribution in the image. The first positive categories in the candidate area should be eliminated. Experimental results show that EFM significantly increase the time required for training, and the PAE can reduce the training time and slightly improve detection accuracy. Finally, the probability-based two-stage CNN improved the PE detection sensitivity from 75.4% to 85.97%. So we got a very good result. That's my presentation. So do you have any question?